All right, so today we're going to talk about vertex form of quadratic equations. Last time we talked about standard form. So just to review, standard form of a quadratic is f of x equals ax squared plus bx plus c. And when we're in standard form, there's a few things that we can deduce from that form. We can always see the y-intercept is at c. The a value tells us the shape of the function. So concave up if it's positive, concave down if it's negative. And then if a is bigger than 1, we'll have a vertical shrink or a stretch, vertical stretch, it will be narrow. And if a is between 0 and 1, a will be wider, a vertical shrink. We can also find the axis of symmetry in the x-coordinate of the vertex using x equals negative b over 2a. And the other thing that we can do from standard form is identify the roots by factoring. So we use standard form for quite a few things, but there are other forms that we will see quadratics written in. So another form that we'll see is vertex form. So where standard form tells us those things, vertex form is this: f of x equals a times x plus h squared plus k, where the vertex of our equation is at h, k. Remember, and we'll keep talking about this, but the sign will flip. So when we move from that grouping symbol in our equation to the actual vertex, just on the x-coordinate, the sign flips. So a couple things. The a value here in vertex form tells us the same thing that the a value told us in standard form. So if a is positive, our graph will face concave up, so it will be an upward parabola. If a is negative, the graph will face concave down, so like this. If a is greater than 1, we'll have a vertical stretch. And if a is between 0 and 1, so like a fraction, like 1/2, or a decimal, like 0.2, we'll have a vertical shrink, which would make our graph wider. So then, in here, for h, in the vertex form, h is the x-coordinate of the vertex. Oops. And we remember that we have to take the opposite sign of how it's written in vertex form. So the h will have the opposite sign of how it's written in vertex form, and that will be the x-coordinate of our vertex. So then k is the y-coordinate of our vertex. So in vertex form, we can see that max or min value of our parabola just by looking. We don't have to plug in negative b over 2a, figure out x, plug it back into the equation. We can just literally look at it and say, okay, I know what my vertex is. In terms of transformations, if we have x plus h squared, it moves our vertex to the right, to the left, because it's going to go the opposite direction of the sign. So because this is plus, it is moving our vertex left h units. If we had x minus h squared, it would go right h units. Same thing with k, except k does exactly what it looks like it's going to do. So when we have plus k outside of those grouping symbols, it moves our graph, our vertex up k units. And if it was minus k, it would move our graph down k units. So then these practice problems say to identify the transformations of each function from the parent function, and then tell me the vertex and the domain in the range. So if I look at number 1, x plus 2 minus 4, inside here I have a horizontal shift, which always goes the opposite direction of the sign. So this is going to go left 2, and then a vertical shift, which goes the same direction as the sign, and down 4. So if my graph, parent function starts at 0, 0, and then it goes left 2, down 4, then I have a vertex at -2, 4. And because this A value is positive, my graph is going to be concave up. So I can kind of sketch what my graph looks like. The vertex of my graph then is at -2, -4. This is -4, down 4. -2, -4. The domain of all quadratics is -infinity to infinity. In my range going from low to high, it will start and include that first y value at -4 on my vertex, and it will continue upward to infinity. And then number 2, in terms of transformations, we have this negative sign, which is going to be a reflection in the x-axis. So it's going to flip my parabola upside down. We have a horizontal shift, and this is going to go right 7 units. And we have a vertical shift, which will move up 3. So the vertex here, after we move right 7 and up 3, will be at 7, 3. So something like this. And because of that reflection, our parabola is going to be facing concave down. So the domain of all quadratic functions, -infinity to infinity, in the range going from low to high, this is coming from -infinity, from the low, all the way to that vertex y value of 3, which we include with a bracket. So one thing you'll be asked to do is to move between forms, to go from standard form to vertex form, or vice versa, from vertex form to standard form. There are 2 ways that we can move from standard form to vertex form. The first is the one that we've already done, which is by using that we know that x equals -b over 2a. So we can find the x-coordinate of our vertex from standard form, find the y-coordinate of our vertex, and then plug them in to vertex form. Using this example, let's find the vertex and put this into vertex form. So x equals -b over 2a. So -4 over 2 times 1. So x equals -2. That is the x-coordinate of our vertex. To find the y-coordinate of our vertex, what do? We plug this in to our original to find the y. So y equals -2 squared plus 4 times -2 minus 3. 4 minus 8 minus 3. Y equals -7. So my vertex is at -2, -7. But they didn't ask us to find the vertex. They asked us to put it in vertex form. So f of x equals x plus 2. We will change the sign, and then the sign of the 7 stays the same. So this is my vertex form. If we kind of worked backwards and found the vertex first and then plugged it back into vertex form. Just always remember this sign switches as it goes inside and outside of that grouping symbol. You must know how to complete the square because I will ask you to do it. So you don't always have to do it, but I want you to know how to do it. We use completing the square to move from standard form to vertex form, and we want to use it when your b value is even. So 2, 4, 6, 8. When b is even, it's a good indicator that you should complete the square. I have written the steps out for you in this box so that you can follow it when you need to complete the square. We'll use the steps right now to go through and do an example. So completing the square moves us from standard form to vertex form. Step 1, we are going to take our standard form and set it equal to 0. So we plug in 0 for f of x so that we have our whole thing set equal to 0. We have it set equal to 0. Step 2 says move the c term to one side. So we are going to move our constant, this c value, off of the side with the x's. So we get the constants on one side and we get the x's on one side, okay? Now step 3, we're gonna do this kind of off to the side. We are gonna divide our b value. What's b? Negative 14. We're gonna divide it by 2. Negative 7. And then we will square that value, which is 49. We take that 49 and we add it to both sides of our equation to keep it balanced. On an equation, whatever you do on one side, you have to do on the other. If we simplify, this becomes 25 equals x squared minus 14x plus 49.
Don't you have to divide 24 by 2 though first?
What? Step 5 says factor the trinomial on the side with the x's. So we are going to factor this trinomial and rewrite it in factored form. What are my two numbers that multiply to 49 and add to negative 14? Yeah, negative 7, negative 7. And we will just rewrite this in factored form, which I could write like this, but I want this to look like a vertex form, so I'm going to rewrite it like this. Then our last step is to move the c back over. And then we end up with vertex form. X minus h squared plus k. Where is my vertex in this equation?
Plus 7, negative 25.
7, negative 25. Use each way once. So you have to factor once, or not factor, you have to use completing the square at least once. For number 1, what do you want to do?
We want to minus 18.
All right, let's do negative b over 2a. I heard that first. So if we do that, we do negative 10.
So do they do the way you just did the negative b over 2a, do the same thing?
Yes.
Then why would we have to do the hard one?
Nah, I like it better. Okay, so x equals, this becomes positive 10 over 2, x equals 5. So the x coordinate of my vertex is 5. To find the y coordinate, I will plug 5 back in. So I get 5 squared minus 10 times 5 plus 18. Yeah, so negative 25 plus 18. The y coordinate of my vertex is 5. And then the y is negative 7. If I asked you to write this in vertex form, we would say f of x equals what?
X plus 7. Plus 5, minus 5.
Yes, minus 5, because we take the opposite of the actual point, squared, minus 7.
Minus 17.
Step 1, well, first set equal to 0. Then move the constant over. So we get negative 17 equals x squared minus 4x. We will manipulate this b to get the completing the square setup that we need. Negative 4 divided by 2 is negative 2. And then we square it, which gives us positive 4.
Why did you divide by 2?
I did.
No, why did you?
That's just the step to complete the square. Divide negative 4 by 2, which is negative 2, square it, and then we will add that to both sides. Plus 4 plus 4. So we simplify on this side, and then we get our trinomial. Once we have that, we'll factor it. 4, negative 4. What are my two factors? Negative 2, negative 2. They have to multiply to 4 and add to negative 4. Then I'll rewrite this in factored form, x minus 2 squared. And the last step, I will bring over the 13 so that I can see my vertex form very clearly. So here's my vertex form. Where's my vertex? plus 2 plus 13. The roots of a quadratic in vertex form. So remember we talked about to find the roots is we factor, we do our x method, but we can only do that when we have the equation in standard form. So if you are given it in vertex form and you're asked to find the roots, you need to, number one, FOIL the binomial in vertex form. I'm going to do an example up here real fast. So if I have like this, step one is to do this. Watch this carefully. You cannot just do this. You have to FOIL it out. So you have to do x plus 7 times x plus 7. So when we FOIL that out, it's going to stay in the parentheses. We'll end up with x squared plus 14x plus 49. Keep everything else brought down. Shh. Then you distribute the 2.
X plus 7, x plus 7.
So distribute the binomial, or FOIL the binomial, then distribute the a value if there is one. Sometimes there's not, but like in this case, there is a 2, then you distribute that. So we would get 2x squared plus 28x plus 1898. Distribute the 2, and then the last step is going to be to combine the like terms. So 2x squared plus 28x plus 94. Then we have standard form. Okay, so distribute and then combine like terms.
If there's no 2, there's nothing.
If there's no 2, then you skip that step. Yeah, and we'll do some examples.
And then after we have that, then we just find the roots.
Yes, and so now you have standard form. You have A, B, C, and now you can factor. Let's do an example.
I thought we just unfactored it. Yeah, we really just unfactored it now.
Plus 2.
No, first square root. Square root, square root. So then we get 0 equals x minus 2. How do I solve for x?
That's 2.
Good. So I get x equals 2. So that one was fairly straightforward because we didn't have a k value. Look at this one. What form is this in? Vertex form. Where's the vertex of this quadratic? -4, -4. But it's not asking us for the vertex. What did it ask us for? The roots. Meaning we have to get it into a form where we can factor. Is this in standard form? No. First step, finally, FOIL. So we are going to do not distribute the squared to both. That will not work. You will lose a term and it will be incorrect. Rather, you are multiplying the binomial by itself. Keep the -4 because that's part of your answer and it needs to be added in at the end. Okay, then we FOIL. So we get x squared plus 4x plus 4x plus 16. Bring that -4 down. And then we can combine like terms. X squared plus 8x plus 12. Okay? What form is this? Standard form. What can I do from standard form? X method. So set it equal to 0. Use our X method. On top we have 12. On the bottom we have 8. What are my two factors? Multiply to 12. Add to 8. So then we'll say 0 equals x plus 6, x plus 2.
So -6 and
Right. So we set each one equal to 0 and solve for x. X equals -6. And then x plus 2 equals 0. X equals -2. Those are my roots. Okay?
Wait, but didn't we have another method for finding this out?
For finding the zeros?
We could have done the square method.
The square method?
What's the one on the other page?
It says find the roots and the vertex of each. What form is this? Standard form. So what should we do first? X method. Let's find the roots. Because we have it in standard form, we can just factor. This looks super familiar. It's literally the exact same one that we just did. Yeah, x plus 6, x plus 2, set it equal to 0. And then set each factor equal to 0. So we have roots at x equals negative 6 and x equals negative 2. So that's good. So far, so good. Now we need to find the vertex. How do you want to do it? I knew you were going to say that. I thought somebody would really go for it. Okay, to find the vertex, we know that the x-coordinate of the vertex is negative b over 2a. So negative 8 over 2 times 1. Negative 4, that is the x-coordinate of our vertex. To find the y-coordinate, what should I do? Plug it back into my original. So negative 4 squared plus 8 times negative 4 plus 12. So negative 16 plus 12, which is negative 4.
Isn't it 16 plus? What? It would be 16 minus 2.
Yeah, it's 16.
Plus 12.
Is that negative 4, negative 4. Okay, last one. Okay, what form is this? Vertex. So which is the easier one to find first? The vertex. Where's our vertex at? 3, negative 16.
Wait, but aren't we trying to find the vertex?
Yeah.
So we just have it.
Yes, because what form is this? Vertex form.
So we don't have to figure out anything else.
What else did it ask us to figure out? Okay, the roots. How do we find the roots of this? We need to get it from vertex form into standard form. Starts by FOIL. So we're going to FOIL this out. Keep the negative 16 so that we remember to add it in at the end. Okay, FOIL. X squared minus 3x plus 9 minus 16. Combine our like terms. So we get x squared minus 6x minus 7. Standard form. In order to factor, set it equal to 0. X method. Oh. What are my two factors? Negative 1, no.
7 and negative 1.
7, negative 7, positive 1, right? So then, write it in factored form, and then solve for each. X equals 7. And these are my roots, or x-intercepts, or zeros, or solutions, whatever they call them in whichever one type of place that you're looking.